How do thermal and magnetic circuit breaker trips work? Have you ever wondered why your circuit breaker trips when you plug in too many devices? Understanding how thermal and magnetic circuit breaker trips work can help you avoid those frustrating moments. Let's break it down. Thermal and magnetic circuit breakers are designed to protect your home's electrical system from damage. They work together in one device to handle different electrical issues. First, let's talk about the thermal trip mechanism. This part is responsible for responding to overloads. An overload happens when too much electrical current flows through the circuit, but it's not an immediate danger. Inside the breaker, there is a bimetallic strip made of two different metals. These metals expand at different rates when heated. As current flows through the breaker, it heats up this strip. If the current is too high for too long, the strip bends due to the heat. This bending action pushes a tripper that opens the circuit breaker, stopping the current flow. The time it takes for this to happen depends on how much current is flowing. More current means the breaker will trip faster. This is why it is called an inverse time trip. Now let's look at the magnetic trip mechanism. This part reacts almost instantly to short circuits, which are sudden surges of very high current. It uses an electromagnet that becomes stronger as the current increases. When a short circuit occurs, the magnetic field quickly pulls an armature, which is a movable metal part. This action moves the trip bar to open the breaker immediately, preventing damage from the sudden spike in current. Together, these two mechanisms allow the circuit breaker to handle different electrical problems. The thermal part protects against prolonged overloads, while the magnetic part protects against sudden short circuits. This combination makes thermal magnetic circuit breakers popular in homes and appliances. In practical terms, if you have too many devices running on one circuit and the current rises slowly, the thermal part will trip the breaker after some time. But if there is a sudden fault, like a wire touching another wire, the magnetic part will trip the breaker instantly to prevent hazards. These breakers can be installed in any position without affecting how they work, making them versatile for home electrical panels. They also include features like arc chutes that help safely dissipate electrical arcs when the breaker trips, improving safety. Understanding these two trip mechanisms helps explain why sometimes a breaker trips immediately after a fault and other times it takes a while when too many devices are plugged in. It's a clever blend of heat and magnetism working together to keep your home safe.